17 elements, the halogen family. They are known as halogens because they are derived from salts. The general configuration of halogens is NS2, NS2, NP5. The general configuration of group 17 is NS2, NP5. As we can see, fluorine, chlorine, bromine as having the general configuration 2s2, 2p5, 3s2, 3p5, 4s2, 4p5. So here we can see the general configuration. Outermost shell is having 7 electrons, 2s2, 2p5, and as we move down the group 1 shell increases. Now coming to the physical state, fluorine, chlorine are the gaseous state at room temperature, while bromine is liquid and iodine is solid. Means as we move down the group, the molecular spaces is decreasing due to the increase in size, and this is a reason the van der Waals force of attraction is also increasing. That is why iodine is occurring as a solid state, though it is a non-metal. Ionic and atomic radii follow the general trend that they are coming. Group 17 is having the smallest atomic and ionic radii in the entire periodic table due to the highest nuclear charge. Because the nuclear charge is very high, that is why group 17 elements are considered to have a very small atomic size. Then, as moving down the group, the atomic size increases. So iodine is having the largest atomic size. Melting and boiling point. Just consider the normal points as we move down the group. The melting and boiling point increases. As melting and boiling point increases because of increase in size, and ionization energy also follows the same trend because of their small size. Ionization energy in the entire periodic table of group 17 is very high because of very high effective nuclear charge. Electronegativity also of group 17 is very high because of the smallest size and extremely high nuclear charge. Their electronegativity is very high in the entire periodic table. Then coming to the electron gain enthalpy of group 17 is maximum in the entire periodic table, and down the group it decreases. But fluorine electronegativity is slightly, electron gain enthalpy is slightly less than chlorine. The reason is fluorine is having a very small size. The fluorine is having a very small size, and because of its small size fluorine is bearing some interelectronic repulsion, and to minimize that some energy is being spended it, and this is the reason fluorine is having slightly electron gain enthalpy less than chlorine. Because of its small size it bears interelectronic repulsion, and because of that fluorine electron gain enthalpy is less than chlorine. Rest follows the general trend. Down the group gain enthalpy decreases. Non-metallic character down the group decreases due to increase in size. So fluorine is having the highest non-metallic character. Oxidation state in group 17 follows from negative oxidation state to positive -1 to +7, but fluorine only show -1 because of its small size and highest electronegativity. Rest other elements of group 17 show oxidation state from +1 to +7, but stability of higher oxidation state down the group decreases due to inert pair effect. Now coming to the next, variable oxidation state, it depends on the excited state also, and the colored, all the halogens are colored because the electrons excitation is easy to moving down the group. So we can see the different colors due to the excitation of electrons on the outermost shell in halogens. Now, the chemical properties of group 17 depends upon the low dissociation energy. The halogens have very low dissociation energy of XX bond because of the high electronegativity in comparison to hydrogen, carbon, oxygen, and nitrogen. They have low dissociation enthalpy because of higher interelectronic repulsion, high electron gain enthalpy, which easily makes them to attract the electron from other atom. They are oxidizing in nature because of low bond dissociation energy that they are having the oxidizing